Hello there. This message is from Harry Potter. See? See? Oh my goodness. Hi, it's Mr. Cox. Coming to you with my head all hurting. Just wanted to get you to talk about some of the rock cycle. Okay? I know this is not new information. I know it's really old information. You learned it last year. You got to beat it into your head. So we're going to breeze through this really quickly. Not very much new information, but we're going to talk about it. We're going to do a project on it. We're going to take a test on it. We're going to be done with it. Okay? So, types of rocks. We got how many different types of rocks? We have 3 types of rocks, right? The first one we're going to talk about is called igneous. In Latin, that term means fiery. Okay, so fiery, right? Well, it just goes to show why we're doing this after volcanoes, because that's exactly where igneous rock is formed, right? That's where it comes from, is when a volcano erupts and that lava spews onto Earth's surface and then hardens, cools and hardens, it hardens into igneous rock. And igneous rock is a relatively hard rock. So igneous rock forms when magma or molten rock cools and hardens. It forms at both divergent and convergent plate boundaries, right? So where we have the mid-ocean ridge moving apart, spewing lava out onto the surface, hardening into new oceanic crust, that's going to be igneous rock, mostly basalt igneous rock. And then where 2 plates are, but we also have to have, it's not just convergence, we also have to have, that's right, subduction. Right, we've got to have subduction. So wherever we have a plate subducting under another, we're going to have convergence and subduction, and that's going to melt the organic material and the plate, and that's going to make the magma that wants to rise to the surface and makes what kind of volcano? Composite volcano, that's right. All right. Some examples of igneous rock, right? A lot of us have it in our homes, in our bathrooms, or in our kitchens, right? Granite. Right here, we've got a piece of granite. Yes, I see. Oh. Okay, so this is, right, unpolished, uncut. It's just a granite rock. But you could see that if I were to polish this, you would have that same look that granite has. This is a picture of granite, right? An uncut, unpolished piece of granite. And then the other one is what's called pumice. Now, where you might have heard pumice, girls maybe more than boys, right? Pumice stones when you go get your nails did, or your hair, not your hair, your feet did, or whatever you do, right? Well, they might use a pumice stone, especially on your feet, to scrape off some of the dead skin. I know it's gross, but scrape off some of the dead skin and polish your feet up, make them look nice and purty, you know. But that's pumice, and that's where a common use for pumice stone comes from. But that is igneous rock as well. Difference between these two: pumice is extrusive, right? It flows onto the surface of Earth and then cools and hardens. Granite is igneous. It might harden inside of a volcano, never makes it to the surface. It might harden as magma inside of a volcano or a magma chamber. And then we go in and we mine it and cut it and shine it up and cut it and slab it and put it in your kitchen. Right? So that's one example, igneous. Okay? The next one, metamorphic. The root or the prefix meta and morphic kind of means to change, right? The word describes to change. Okay, so metamorphic rock forms when existing rock is exposed to extreme heat and pressure. Where might that heat and pressure come from? Inside of Earth, right? So these are layers of rock that have been pushed way down, almost to the bottom of the crust, right close to the mantle, where there's a lot of heat coming from the mantle and a massive amount of pressure. Well, what happens is the layers start to squish and they kind of get flattened out like a pancake, right? So that's where metamorphic rock comes from. So you might see some some wavy layers, they're not straight layers, but some wavy and some folded layers of rock in a metamorphic rock, and that's because of the intense heat and pressure that it's under. Some examples are gneiss and schist. Holy schist! Got a big pile of schist over here. Let's take a look at it. Okay? I know it might be hard to see. Ooh, but that's my schist. I'm holding this big pile of schist right here. In class, we'll take a look at my schist, and we're going to see that these layers are, you can see kind of the wavy layers of sediment that have been compressed and flattened like a pancake. Okay, so here's an example of metamorphic rock. It's a pile of schist, and I don't have one of gneiss, but we do have some pictures, right? So here you can see wavy layers of sediment that have been squished like a pancake. Same thing here, right? You can see that here's kind of a layer that is riding the wave, right? And that's because this intense heat and pressure that rock undergoes deep within the Earth's crust, close to the mantle, we get intense heat and pressure, and that morphosizes or changes the rock into metamorphic type or style of rock. Now, where might this occur? Right? This only occurs at convergent plate boundaries. Why? Because that's the only place that we have massive amounts of pressure buildup in Earth. Okay? So, that's where we're going to see metamorphic rock, a majority of metamorphic rock. Now, the last one is the easiest. It is sedimentary. Okay, sedimentary rock forms at the bottom of waterways, right? Where sediment is deposited into layers. So we have this thing called weathering and erosion, right? So weathering would be where particles are broken down. So rock is broken down into little tiny pieces called sediment, right? And that sediment then gets carried away, and that's called erosion, right? Whether by wind or rain or wind or water or ice, it's going to carry that sediment away into a stream or into a river or into the bottom of a lake. And then it settles at the bottom of that lake or that river or that stream or that pond or that ocean, right? And it's going to settle into layers over time. And then those layers kind of get pushed down and cemented together. Mineral deposits kind of fill the gaps between all of the different pieces of sediment, and they kind of glue it together and cement it together, making it sedimentary rock, right? So we've got rocks, mineral crystals, and organic matter that have been broken down into fragments called sediment, right? It's carried away and deposited by wind, water, and ice, and then it's deposited, compressed, and cemented together and hardens into sedimentary rock, okay? Now, sedimentary rock can form anywhere where there's waterways. It doesn't have to be at a plate boundary, which is unique to sedimentary rock. Metamorphic and igneous have to be at a plate boundary, or they form at plate boundaries, typically. Right? We've got hot spots. Igneous rock's going to form at hot spots, but typically they're going to be, metamorphic and igneous rock is going to be around the plate boundaries, the edges of our boundaries. Examples. One example is called sandstone. I've got an example here, or I've got a sample here. Here is sandstone. You can see the different layers of the sediment laid down over time, and then they were cemented together. I hope it was focusing. Sandstone. Sandstone. Right? So this is exactly what it's sand particles, right? Small rock, tiny fragment particles that have been cemented together. And then limestone, it typically is made in oceans where there's old coral reefs and old organic material like seashells that break down over time into layers at the bottom of the ocean. And then those layers get compacted and cemented together, and they form a layer of limestone. Okay? Here are two examples. So this looks pretty close to the sample that I just showed you, where you see the layers. Okay? And you've got different color sediment and different thickness layers and so on. And then you've got limestone. Limestone is a much smaller sediment and a much more uniform stone. So it's going to look, you're not going to have the layers like you do with sandstone. But limestone is another example of sedimentary rock. Okay? Now, this last slide is just talking about vocabulary. Two of them we've already, well, really all of this we've talked about already, but we're just going to highlight it really quickly. Weathering, when rocks are broken down into smaller fragments, right? Wind, rain, ice, sleet, snow, all of that can break rock down into tiny fragments called sediment, right? So that's weathering. And then when that wind, rain, ice, snow move that sediment somewhere else, maybe it falls into a river and that river carries the sediment down, that's going to be erosion. And then over time, maybe that river opens up into a lake. Well, when the river opened up into a lake, the flow of the water slows down. So what happens to the things being carried by the water? They drop out of solution. They drop out and sink down to the bottom of the lake. So the bottom of that lake is going to build up layer after layer after layer of sediment that the river is carrying to it. So that's called deposition, right? The depositing of the rock fragments down at a new location. Igneous, formed by cooling and hardening of hot rock. Sedimentary, formed when sediments are pressed and cemented together. Metamorphic, formed when rocks are changed by heat and pressure. Let's take a look at a video that shows you how all of our rocks interact with each other with something called the rock cycle. Let's try it again. Woo! Slippery little bugger.
The rock cycle is a sequence of events that describes the possible fates of a rock as it is transformed from one type of rock to another. The fate of a rock is determined by its location. Let's follow one pathway a rock may take through the rock cycle. Our rock begins as molten rock material, or magma, deep inside Earth's crust. The magma erupts through a volcanic vent and flows down the cone in a river of lava. The lava cools and new igneous rock is formed. Because the rock is exposed at Earth's surface, it is vulnerable to weathering and erosion. Agents such as wind, water, and gravity break the igneous rock into small pieces called sediments. These are washed into the river and carried away. The river slows down as it empties into a lake. The water can no longer carry the weight of the sediments, and gravity pulls them to the lake bottom. Layer after layer of sediments are deposited in this way. The weight of the top layers pushes down on lower layers, compacting them. Even though they are compacted, space remains between the sediments. Over time, minerals form in these spaces. These minerals act like a glue and cement the grains together. The rock material that began as igneous rock has been transformed into sedimentary rock. The rock is buried deeply beneath Earth's surface. There are many forces acting on the rock. The rock is pushed, pulled, and squeezed by tectonic forces and the weight of the overlying layers. These forces, combined with the intense heat deep inside Earth, bend and change the rock, giving it different properties. The rock is now metamorphic rock. Observe how the forces acting on the rock have aligned the grains, creating banding patterns. Over time, the metamorphic rock may be pushed deeper into Earth's interior, where it melts and once again becomes magma. This is only one possible pathway through the rock cycle. Given the right conditions, any rock can be transformed into any other kind of rock through the dynamic processes of the rock cycle.
So to reiterate what that video was talking about, it just highlighted one way, right? It went from igneous to sedimentary to metamorphic, but an igneous rock could go straight to metamorphic rock, or a sedimentary rock could go straight back to igneous, right, to a magma, without becoming a metamorphic rock. So all of them can become one another, right? There's not just one simple cycle that we can travel around. No, igneous can become metamorphic, metamorphic can become igneous, igneous can become sedimentary, sedimentary can become igneous, sedimentary can become metamorphic, metamorphic can become sedimentary, right? All of them work together, okay? We're going to talk more about this, but this is just kind of the highlight of everything put together. We've got the three different types of rocks and then the interactions between them. Okay, so I'll check you later. Peace out, home skillets.